This is our Summer Math Week 5. Simplify the expression. We will begin by distributing the number outside of our parentheses. Negative 1 times 5 will be a negative 5. Negative 1 times 3x will be a minus 15x. Distributing minus 8. Minus 8 times 1 will be a minus 8. Minus 8 times minus 4 is a plus 32x. Combining like terms, minus 15 times plus 32, minus 15 plus 32 will be a plus 17x, minus 5 times minus 8, minus 5, subtract 8 will be a minus 13. Technically what we should do are change all these additions to subtractions, so this Technically what we should do is change our subtractions to additions. So this minus 15x becomes a plus a negative, and this becomes plus a negative, and then we can use the commutative property to rearrange and then combine our like terms, but we will end with this result. You can see 32x plus a negative 15x would be a 17x. Negative 5 plus a negative 8 will be a minus 13. Solve the equation. We will begin by distributing the 8 over this parentheses. So 8r. 8 times 7r will be a 56r. 8 times 7 will be 56. Combining like terms, 8r and 56r will be a 64r. Plus 56 is a negative 136. Subtracting 56 on both sides. 64r is a negative 192. Dividing both sides by 64. R will be negative 3. You could take that negative 3 and substitute it back in and see that it yields a true statement. Solve for the indicated variable. In this case, we're solving for x. We have x times c. To get that x by itself, we will simply undo the divide by c. Well, c divides c to leave x. How do I write this? R divide d divide c. You could write it just like that. R divided by d divided by c. Equivalently, we could say x is equal to r divided by the product of d times c. And this makes sense. Here we're multiplying these two things together, and then we're doing r divided by that. Another way to say this is multiplying by 1 over c. Either of these two expressions are equivalent. These two right side expressions mean the same. Solve by factoring. When we solve by factoring, we first set the equation equal to 0. Done. Now we're going to factor this left-hand side using our big X method. I'm going to leave the big X method to you, but we know that it's going to be m and m. To multiply to give 10, it's only 10 and 1 or 5 and 2, and this one's going to be a 5 and 2. M times m is m squared. 5 times 2 is 10. 5m and 2m will be 7m in the middle. Now setting each one of these factors equal to 0, this is our zero product property. M plus 5 is equal to 0, or m plus 2 is equal to 0. If two factors multiply to give 0, one of them must be 0, or both. Here subtracting 5 from both sides, we get m is minus 5. Here subtracting 2 on both sides, we get m is minus 2. These are our two solutions. M is minus 5 and minus 2. Solve by completing the square. When completing the square, the first thing we do is gather our variables on one side and our constants on the other. In this case, I'll add 29 to both sides. So we're left with b squared plus 14b is equal to 3 plus 29 will be 32. Now we're going to add in a box number on both sides. This box number is a special constant that's going to turn our left side expression into a perfect square trinomial. This box number will be 1/2 of b quantity squared, where b comes from our form ax squared plus bx plus c, standard form of a quadratic. So in our case, b is 14. So 1/2 of 14 squared. Half of 14 is 7. 7 squared is 49. Our box number will be 49. Alright, now our right side we can write as a binomial squared. Our left side, combining like terms, yields 81. The square root of the first term goes first. The square root of the last term goes last. And this operator goes in the middle. Now we can take the square root of both sides. The whole reason we wrote that box number in is so we can now conveniently take the square root of this quantity squared. The square root of 81 will be both positive and negative 9. And taking the square root of something squared, they're inverse operations. They cancel each other, leaves us with b plus 7. Now we write this as two separate equations. One is b plus 7 is a positive 9, and the other, and b plus 7, is a negative 9. Solving both of these independently, here subtracting 7 on both sides, we'll leave that b is 2. Here subtracting 7 on both sides, we'll leave b as negative 16. These are our two solutions. B is 2 and b is negative 16. You could substitute that back in the original to verify. Factor each completely. When we have 4 terms, we attempt to factor by grouping the first 2 and the last 2. Here, hopefully you see that between 12 and 10, 2 is the GCF. Between k cubed and k squared will be k squared. If they both have the variable, we can factor some out in the least power. 12 divided by 2 is 6. K cubed divided by k squared is k. Minus 10 divided by 2 is 5. K squared divided by k squared would be k to the 0, which is 1. 5 times 1, just leave 5. Between 30 and 25, 5 is the GCF. Cannot factor out a k, they both don't have it. 30 divided by 5, 6k. Minus 25 divided by 5, minus 5. Now observe they both have this common binomial of 6k minus 5. We can factor that out. Factoring out the 6k minus 5 leaves 2k squared. From the second portion, factoring out the 6k minus 5 leaves the plus 5. Factor the common factor, the greatest common factor. Hopefully you see they all have an x. We can factor out the least power, in that case x to the first. Here we have a minus 9, plus 9, and a 21. They all have a common factor of 3. Now, since the leading term is negative, I'll factor out a negative. That's not a hard, fast rule. It's sort of a rule of thumb. It is frequently, it's nice in terms of factoring if our leading power has a positive coefficient. Negative 9 divided by negative 3 is a positive 3. X to the fourth divided by x to the first is x to the third. 9x cubed divided by negative 3x will be a minus 3x squared. 21x divided by minus 3 will be a minus 7. And don't believe we're going to be able to factor this one any further than it currently is. Factoring completely, 2k squared minus 8k minus 5. Hopefully you see the GCF of 2. So factoring out that first leaves k squared minus 4k minus 5. Now we could use our big X method. I know that k squared is going to be k and k. In the bottom we have a times c, in the top b. In our case, a times c will be 1 times minus 5. It's a minus 5. RB is minus 4. Since this is a negative, 1 will be plus, 1 will be minus. 5 is prime, 5 and 1. It has to be negative 5 and positive 1. These will go here. Plus 1 minus 5. We could distribute a check, but it will be correct. Evaluate each expression. When we have a subtraction, we keep the first sign the same. That is the sign of the top, the first number, also called the minuend. Changing the subtraction to an addition, changing the sign of the second number, the subtrahend. Negative 2 minus negative 4 is equal to negative 2 plus 4. When the signs are different, simply subtract the numbers and keep the one with the highest absolute value. 4 is more than 2, so we got 4 positives. The result is positive. Find the product. Product is the answer to a multiply. Multiplying, distributing the 2p across this parentheses. 2p times 4p will be an 8p squared. 2p times minus 7 minus 14p. Distributing the 3. 3 times 4p will be a 12p. 3 times minus 7 will be a minus 21. Combining these two like terms, 8p squared minus 14 plus 12 will be a minus 2p minus 21. Oftentimes the product of a binomial and a binomial will be a trinomial, 3 terms, because we get these like 2 terms inside. Simplify. We're multiplying this radical expression, this expression with a square root, times these inside. Consider this expression here to be 1 times the square root of 10. It's certainly easy for you to imagine this implied coefficient, you might say, of 1. Multiplying negative 3 square root of 5 times negative 3 square root of 6. Well, negative 3 times negative 3 is a positive 9. Square root of 5 times square root of 6, you simply multiply the radicand, the underneath part. That makes sense. 5 times 6, 30. Still underneath the square root. Negative 3 times plus 1 will be a minus 3. 5 times 10 will be 50. Now we look for these radicand. This underneath part is called the radicand. We look for perfect squares that are factors. 30 has no perfect square that's a factor of it, but 50 does. 50 is 25 times 2. Square root of 50 becomes square root of 25 times square root of 2. Well, square root of 25 is 5, so the 9 square root of 30 stays the same. Square root of 25 is 5, 3 times 5 is 15. So we have 9 square roots of 30 minus 15 times square root of 2. I don't need this multiply operator. I simply could have connected it. Connected means multiplied. Alright, when we are subtracting a polynomial expression, you could consider this a plus negative 1 here. It's like we're distributing a negative 1. We're subtracting each one of these quantities. It becomes minus 7n cubed, minus 6n4, and minus 1. That makes perfect sense. We were subtracting each one of these things. That's what we've done here. I don't need the parentheses around my leading polynomial. Now it's a matter of combining like terms. N to the 4th is like n to the 4th. 3 minus 6 will be a minus 3 n to the 4th. N to the 3rd is like n to the 3rd. 5 minus 7 will be a minus 2. This should see an n there. N to the 3rd. Lastly, 5 minus 1 will be a plus 4. And that concludes this video.